Hello, Algebra 2 folks. This is Ms. Backfish, and I am on page 25 of your pink practice and activities packet from Unit 2. And this is something that we skipped over just because we were short on time and it wasn't going to be on your test. But it's something that's worth looking at just because you might see it again. Well, you almost certainly will see it again someday, but this is something that could come up again in the semester. So I want to make sure you've seen it. So basically, this is two variable inequalities, meaning there's an x and a y, word problems. Okay, so we're combining two things we know how to deal with and just dealing with them both at the same time. So I would encourage you first to go ahead and look at this paragraph and see if you can write two inequalities, two separate like equations, but not equations. They should have a greater than or a less than or equal to or greater than or equal to. So go ahead and hit pause and see if you can write two inequalities that go with that information. And then when you're ready to, hit play and see if I get the same two inequalities you did. All right, so here's what I'm going to get. An event planner wants to order some ice sculptures as decorations for a company party. That's just background information. That's not giving me anything mathematical. The next sentence starts to give me some information math-wise. Small sculptures cost $150. Large sculptures cost $510. And the maximum budget for this portion of the party is $2,550. Okay, so this says write the inequality in standard form and draw a graph that describes the situation. First off, let me just remind you, standard form is like you have the x and the y on the left. They have numbers in front of them like a and b that are positive. Well, a needs to be positive, b could be negative, and they are integers, meaning not fractions, not decimals, like whole numbers and maybe a negative whole number. And then on the right-hand side, and it could be a greater than or equal to or whatever's here. Let's just draw a little star. This is where you just have a number, meaning the constant. That's the C. So let's make a C for constant. So that's standard form. So when it says to write it in standard form, that's what we're going to have to do. All right, so let's see what we've got here. Small sculptures cost $150. Large sculptures cost $510. And then they give me the maximum budget. Well, I would say if I want to know how much it's going to cost me, let's think about, if you actually knew how many small sculptures and how many large sculptures you wanted, what would you do? You would do $150 times the number of small sculptures. So I'm saying let x equal the number of small sculptures. And then you would take 510 and multiply that times the number of large sculptures you have. So y is the number of large sculptures. And again, if you're having trouble thinking about this, you could be like, okay, well, what if somebody told me, like literally pick a number. What if I had 10 small sculptures and 5 large ones? How would I figure out how much it was going to cost? I would do 150 times 10 plus 510 times 5. So that can help you realize, okay, so the number of small sculptures is written with the 150, and the number of large sculptures, that variable is going to be written with the 510. So, okay, that is the left-hand side. That is the AX and BY part. Then we know that the maximum budget, that means I need this to add up to less than, or it could equal, we can actually pay this much, $2,550. So that is my inequality, okay? So that is written in standard form, and then I need to draw a graph. So in order to draw a graph, I'm going to need to label my axes. So my x-axis here, we said that was the number of small, okay? So number of small sculptures, and the y-axis represents the number of large sculptures. And I'm going to try and make those a little bit more legible. And go. Okay. Did a little bit better with that one than I did with this one. Let's try it one more time. There we go. Okay. So let's see. I think the easiest thing to do, since it's in standard form in terms of graphing, is x and y intercepts. And remember, to find your x-intercept, you plug in 0 for y, which is like making this whole term equal to 0, because 510 times 0 is just 0. So it's kind of like this whole term just disappears. And now you're just dealing with these parts. And then when we go back and try to find our our y-intercept, we plug in 0 for x, which means this whole term becomes 0, which means it's like this disappears, and this is all we have to deal with. Okay, so we're finding the x-intercepts. They would be the same for the equation, so we can treat it just like it's equals for a second, because the fact that it's not an equals, that's dealt with two ways. It's dealt with whether by figuring out whether we make it a dashed line or a solid line. That's one way. And by figuring out where to shade. But the location of it is going to be the same as if it's a line. So 150x, plugging in 0 for y means I just need to look at this, because that term just basically disappears when I plug in 0 for y. And so I'm going to divide both sides by 150. And do I have a calculator handy? Let's see, 2550 divided by 150 is 17. So my x-intercept is 17, meaning my line goes through the point 17, 0. All right, and for space, I'm going to go ahead and just make this a little smaller, if it'll let me. Move it over so I can do the same for the y's. So for my y-intercept, it's like I'm putting a 0 in for x, so it's like that disappears. Okay, so 510y equals 2550. So 2550, 2550 in my calculator divided by 510 gives me 5. So y equals 5, so the point 0.05 is where my line goes as well. Okay, so now I have 2 points I can graph the line. The next thing I need to think about, because this isn't an equals, it's an inequality, is will my line be will my line be dashed or solid? And the answer is solid because of that little line segment right there. Okay, so I'm going to draw a solid line. I think I might have 17 little tick marks here on my grid, so let's see if I do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. There it is. There's 17, 0. And then I can go up 5. 1, 2, 3, 4, 5. And there is 0, 5. So I can just draw a line that goes through those 2 points. And that is my line. Okay, now the next thing I need to know is where to shade. If you think about what this problem is asking, I bet that will give you the answer. Even before you think about maybe plugging in a point to try. We're trying to stay under budget. We're trying to stay within the budget. If I pick, if I'm allowed to have up to, I could have 17 small sculptures, that means 0 large sculptures. Or I could just have 5 large sculptures and 0 small sculptures. Then if I pick some number way out here, that's like, I don't know, let's say 20 small sculptures and maybe, 8, 9, 12 large sculptures, that's going to be way over budget. Because anything more than 17 small is over budget. Anything more than 5 large is over budget. And these are all combinations in here that I could get. Like maybe I could get, this is 1, 2, 3, 4, 5. 5 small and 1 large. This one would be like 3 small and 2 large. All of those are fine. But anything over here, this is all over budget. So I am going to shade beneath there because that's where the possibilities that will keep me in budget are located. So I'm going to shade right in here. Now, other than just thinking it through, you could have picked any point on either side of the line and plugged it in. Like one of those points I just picked. Like, for instance, let's use one of those. This was the 0.32. I can plug in a 3 here and a 2 here and see if that does indeed work. So 150 times 3 plus 510 times 2, that's what? 450 plus 1,020, and that would be 1,470. Is that less than or equal to 2,500? Yes, it is. So that's fine. So I know that it can shade on that side of the line, on the same side of the line where that point is located, because that point is in what we call the solution space. All right, let's go ahead and do the next one. Again, especially if you didn't try it last time, go ahead and hit pause and try this. It says, suppose your class is raising money for the Red Cross. You make $3 on each basket of fruit and $5 on each basket of cheese, box of cheese, that you sell. How many items of each type must you sell to raise more than $100? Write the inequality and draw a graph in standard form that describes the situation. So again, hit pause, try it yourself, and now it's my turn. You make $3 on each basket of fruit. So I'm going to say, let's let X be the number of fruit baskets. Okay. Then if I wanted to know how much money I was going to make from all the fruit baskets I sell, I would do $3 times the number of fruit baskets I sold. Then let's let Y be the number of cheese boxes, or boxes of cheese. And then if I wanted to know how much money I made on all the cheese that I sold, that would be $5 times the number of boxes of cheese I sold. Okay, if I take those two amounts, this is all the money I make on fruit baskets, and this is all the money I make on cheese boxes, and I add them together, I'm going to have all the money I made, period. Okay, so I'm getting rid of my underlining, and I accidentally got rid of my Y. I'll put the Y back. All right, so how many items of each type must you sell to raise more than, this is telling me what I need to do. I need this to be more than $100. Does it say or equal to? No, it wants to be more than $100. So this is what I'm trying to graph. So again, it is already in standard form the way we wrote it. Okay, this is like my AX plus BY equals C, or is greater than C in this case. So it's in standard form, and when it's in standard form, the easiest way to graph is to do the x-intercept and the y-intercept. So let's do our x-intercept first. 3x equals 100. I'm doing equals because I'm just finding the location. And remember, this is like I plugged in a 0 for y and all that went away. Okay, so x equals 33 1/3. 33.3 repeating. Then 5y equals 100 is what I get when I plug in a 0 for the x. All of that disappears. So y is 20. So this has given me 2 points on my graph. There's one on the x-axis, and here's one on the y-axis. Now let's look at my grid. We already said x was the number of fruit baskets. So I'm going to put that on the x-axis. Fruit baskets. And y is the number of cheese boxes. Wouldn't a cheese board make more sense? I don't know. Cheese boxes. Okay. We need 33. I don't think there are going to be 33 little tick marks here. So maybe I need to go by, I could go by 2s. I could go by 5s. And I could even go by 5s and have it be like maybe 3 boxes make 5. That would be interesting. Like 5, 10, 15, 20, 25, 30, 35. That could work. Okay, so 5, 10, 15, 20, 25, 30. And this is 30. This is 35, so 33 and a third would be maybe about right there. Let's go ahead and say it's about right there. Then for y, if I'm going to do the same thing, let's go up. Through 3 boxes is going to be 5. 5, 10, 15, 20. There it is, right there. There's 20. So now I can connect those, but I do need to think at this point, before I draw any lines, I need to think about whether they're going to be dashed or solid. And this one is going to be dashed because it does not have an or equal to. So strictly greater than. All right, there we go. My dashed line. And it says, I want to know how many must I sell to raise more than 100. So I'm trying to get more than this amount. I think all this area is less than 100. If I only sell, let's think about if you sell 0 fruit zero fruit baskets and 0 cheese boxes, you get less than $100, right? So the place I'm going to find more than here is above that dashed line. So I'm going to shade rather from here up. And there you have it. Thanks for watching. Thanks for completing this page. And looking forward to moving on into systems of equations that we kind of started today. These are not systems of equations. These are just leftover information from our last unit because each one of these, we only had one equation. A system of equations, remember, is 2 or could be more that we're trying to find a solution that works for all of them. These are just single inequalities, really. They're not equations, but single inequalities. Thanks for watching. See you next time. Bye-bye.